Assalamu alaikum. My name is Mehak Timotheus and I am from BS Biotechnology. And the topic of my presentation is atom economy. So, when we listen to word atom economy, the first question that tries in our minds is what is atom economy? So, I am going to give you a little introduction on atom economy. Atom economy is basically a measure of the amount starting material that ended up as a useful products. It is the conversion efficiency of a chemical process in terms of all atoms involved and the desired products produced. The concept of atom economy and the idea of making it a primary criterion for improvement in chemistry is a part of clean chemistry movement. Atom economy is the second principle of clean chemistry that comes down to preventing waste on a molecular level. It is an example of a clean chemistry metric which helps us understand the efficiency of a reaction. The principle of atom economy. Atom economy is the reduction, not the elimination, of all the atoms introduced in the process that do not end up in the desired product. This idea came together with the desire to be able to measure rationally the created waste, and several criteria of atom economy were thus crafted. There is a question why it is better than waste. So, atom economy measures the efficiency of a reaction by revealing how much reactant will be used in forming a desired product. A higher atom economy means we have a less wasteful and more environmentally friendly reaction. The atom economy assumes 100% yield for all the products involved. Now, I'm going to tell you the importance of atom economy in chemistry. Atom economy are important concepts when we design a chemical reaction to ensure sustainability. For example, a reaction may have 100% yield but still generate more waste than product. It reduces the use of non-renewable resources, minimizing the amount of waste and reducing the number of steps in chemical synthesis. It also encourages the efficient use of raw materials, reduces the production of waste byproducts, limit the potential environmental impact of a reaction. Using fewer materials can reduce cost, sustainable development, and use reactions with high atom economy. By continuing, atom economy is important in chemistry because it provides a way to compare different reactions and determine which one is the most efficient. Now there is a small definition of atom economy. It is the ratio between the mass of desired product to the total mass of products expressed as a percentage. As you can see that this is a formula of atom economy. Atom economy is equal to molecular weight of desired product divided by molecular weight of all products and multiply by 100, and we get the answer in percents. By continuing, atom economy is calculated by dividing the total number of atoms in the desired product by the total number of atoms in all the reactants. For example, if a reaction produces 100 atoms of a desired product and 200 atoms of reactants, the atom economy would be 50%. There is an example. If we consider the reaction A plus B as a reactants and C plus D as products, where C is the desired product, then atom economy is equal to mass of C over mass of C plus D. Optimal atom economy is 100, where mass of C is the mass of desired product and mass of C plus D is the total mass of the products. There is a further explanation that how atom economy can be calculated. These are some steps of calculating atom economy. First of all, write out a chemical equation for the reaction, then balance the chemical equation by calculating the mass of each reactant and add the masses to find the total mass of the reactants. Then calculate the mass of each product and add the masses to find the total mass of the products. If the total mass of reactants is not equal to the total mass of the products, a mistake has been made and an equation is not balanced. So double check the math to find the error. Then calculate the mass of just the desired product and divide it by the total mass of the products and then multiply this number by 100 and record the answer as a percent. Here are some real-life examples of atom economy. Since atom economy also means atom efficiency, scientists are looking for the most efficient way to produce a desired outcome. Some atom economy examples are steam reforming and electrolysis as methods for creating the desired product hydrogen. Here is another example of atom economy, which is also the example of low atom economy, making hydrogen from electrolysis. Relative atomic masses of sodium, chlorine, hydrogen, and oxygen. Electrolysis for aqueous sodium chloride solution. As we see in the formula or the introduction in atom economy, we have to calculate the total mass of reactants and then we have to calculate the total mass of products. Then we have to divide the desired product mass of desired product to the total mass of the products and multiply it by the 100 and we got the answer in percent and it is the 1.31%. There is another example of low atom economy. As we can see that there is a methane. We react the methane with 2 molecules of oxygen and we got the desired product of 2 molecules of water and we add and we add carbon dioxide. There is a total mass of reactant atoms, total mass of desired products. As we see in the formula, we do all the things and multiply it by 100 and we got the answer 45%. Here is an example of high atom economy. It is a synthesis of ammonia from nitrogen and hydrogen. By the reaction of methane and water, we got nitrogen and 3 molecules of hydrogen. We calculate the mass of nitrogen and mass of ammonia. But in this case, which is high atom economy, we have to add the mass of nitrogen. We have to add the masses of methane and water also to the total mass of the products and then multiply by 100 and we got the 54.8% ratio. High atom economy produces a high percentage of the desired product using a minimum amount of reactants, and low atom economy produces a low percentage of the desired products using a large amount of reactants. As you can see the difference between the low atom economy and high atom economy, because low atom economy gives us 1.31 percentage and high atom economy gives us 54.8 percentage. Low atom economy gives 45 and high atom economy produce 54, which means that low atom economy always gives us small or less percentage of atom economy. High atom economy links to sustainability. Industries always want a high atom economy. This means that the value and sustainability of a certain product will also be high. Here are some impacts of atom economy on sustainability, efficiency, and reduction. Atom economy is a concept developed to quantify the efficiency of chemical processes. It is aimed to minimize the waste production. This helps to improve sustainability, efficiency, and reduce the energy used for synthesis products. Now we are going to discuss the impacts of atom economy on sustainability. Atom economy is related to sustainability in chemistry because it provides a way to measure the efficiency of a reaction and determine its impact on the environment. High atom economy means that less waste is produced, fewer resources are used, and the reaction has a lower environmental impact. By optimizing atom economy, chemists can contribute to a more sustainable future. For example, in a circular economy, companies can design their industrial processes to take full advantage of the atom economy and increase their sustainability performance. Now we're going to discuss the impact of atom economy on efficiency. The impact of atom economy and efficiency is that higher the atom economy, the more efficient the reaction. It also has the impact on reduction. It is that high atom economy means that less energy is needed to carry out the reaction, which can make it more cost effective. There are some benefits of atom economy. Atom economy reduces the use of non-renewable resources. As I told you, it also reduces the steps used to synthesize chemicals. It also minimizes the amount of waste. Atom economy reactions are more sustainable and the amount of starting materials end up as useful products. By continuing my topic, I'm going to tell you about strategies to improve atom economy. First of all, use non-toxic chemicals. entry agents to reduce steps in process, better control over reaction conditions, careful product design, waste minimization, use of more efficient production processes. Additionally, combinatorial chemistry and microfluidic technology. It cannot be improved by one or more complete reaction or by reducing loss of reactants during the process, as is the case with percentage heat. Reaction optimization techniques. I'm going to tell you about more explanation about combinatorial chemistry and microfluidic technology. Firstly, combinatorial chemistry. It involves the synthesis or biosynthesis of chemical libraries of molecules for the purpose of biological screening, particularly for lead discovery or lead modification. Microfluidic technology. It is the use of miniature components in a fluid handling system. It involves the integration of mechanisms which handle, control, and measure liquids in channels and pipes smaller than 1 millimeter. This technology is used in a variety of industries including drug delivery, diagnostics, and lab-on-a-chip applications. Here are some current trends in atom economy. The latest research on atom economy focuses on using chemical processes to minimize waste and maximize efficiency. Atom economy is a measure of the extent to which material and energy resources from the environment are incorporated into useful products. Some technologies and methods that can aid in achieving an improved atom economy, including biorefining, green chemistry, and reaction engineering. First of all, we discuss about biorefining. It is the process of building multiple products from biomass as a feedstock or raw material, much like a petroleum refinery that is currently in use. A biorefinery is a facility like a petroleum refinery that comprises the various process steps or unit operations and related equipment to produce various bioproducts, including fuels, power, materials, and chemicals from biomass. Industrial biorefineries have been identified as the most promising route to the creation of a new domestic bio-based industry producing entire spectrum of bioproducts or bio-based products. Now, I'm going to tell you about green chemistry. It is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, and ultimate disposal. Now, chemical reaction engineering. It is a specialty in chemical engineering or industrial chemistry dealing with chemical reactors. Frequently, the term relates specifically to catalytic reaction systems where either a homogeneous or heterogeneous catalyst is present in the reactor. Sometimes a reactor is not present by itself but rather is integrated into a process. For example, in reactive separation vessels, retorts, certain fuel cells, and photocatalytic surfaces, the issue of solvent effects on reaction kinetics is also considered as an integral part. Now, there are some limitations and challenges that atom economy faces. It does not give any information about reaction yield selectively or the nature of waste. It does not account for catalysts and reagents. It does not give any idea about energy of the reaction. And higher the atom economy, the small the cost of the reaction. Here are some references from which I took all the information about atom economy. At last, at last, I would like to give some additional information about atom economy. That is, in the formula of atom economy, I show you the formula of atom economy. So, in the formula of atom economy, we can divide the mass of desired product by the total mass of the product or reactants. We can use any of them because, according to the law of conservation of mass, both the total masses of products and reactants remain same. The reaction which produces only one product have high atom economy. As you can see in the formula of high atom economy, it produces only one product, which is ammonia. And the reactions that produce more than one product have low atom economy. As you can see that in the low atom economy, there is two products that the reaction made or produce. And in the case of synthesis of ammonia, we will divide the mass of desired product with the total masses of the reactants because we have only one product. That's all. Thank you for your time. I hope you have understand all the points I have discussed. If you have any question, you can ask me in the comment section. Again, thanks for your time.